we're gonna start with this one. I want to go through this one and then just kind of create a couple extras. Get at least, I want you to have at least 4 examples of these to kind of mess around with, so that you can use those on your homework. And then we'll get down to the story problems, which you'll see then when you create the proportion in your story problems, they're not going to be algebraically as difficult as what these ones here are. But some story problems eventually down the road, maybe towards the end of this year and maybe even the beginning of next year, you might create from a story problem a proportion that looks like what we're working on right here. But using the concept that we talked about yesterday, if we have a proportion, which by definition means you have a fraction or a ratio equal to a fraction or a ratio, okay? That's the only time that you can cross multiply. So if I were to have maybe something like, plus 5 over here, this is a ratio equal to a ratio plus another ratio. So that's not a proportion. Does that make sense? All right. It has to be 1 ratio equal to 1 ratio. So yesterday we talked about how we're just going to take those two things there. We called those the extremes, and we're going to multiply those together. So I'll take 5 multiplied by x minus 2. Okay. We're then going to take these two things and multiply them together. So I'm going to take 3 and multiply by x plus 3. Okay. I'm a fan of writing that out because then it reminds me what my next set of algebra is. Okay. Some people, when they highlight their means or extremes or whatever, they go straight to this next step. So some people, once they write this, they know that they need to distribute. And I think after you do enough of these, maybe you can do this, but I would caution you that this step here is important to write down for the time being. So when I distribute, I get 5x minus 10. Over here, when I distribute, I get 3x plus 9, right? Okay, so some people at this stage, guys, when they highlight or look at their extremes, they're just going to do that multiplication right away and get this step. They'll do that and get this step, and that's fine. But if you're a person that does that and you're getting these wrong, make sure that you are actually distributing. The number one error that I see here is that, let's say when we get the 5 times x minus 2, a lot of people will write that as 5x because they distribute the 5, and then they'll write minus 2. They forget to distribute that 5 to the minus 2. Does that make sense? So just be careful with that. That's the number one error on these. So now this generates a equation. If we think about this, this is coming from section 2.4 or 2.5. So we've already worked on these types of equations, and that's the idea of the entire system of mathematics. Every time that you're in a new section, the idea is that you could potentially generate something that you've already mastered, something that you've already shown that you've worked on. Okay. Now we're maybe at different levels in our mastering of this stuff, but with equations like this, x's on both sides, we need to put all our x's on one side, right? So I'm going to leave that 5x there. So how do I get this 3x over there with it? Subtract 3x. And I come over here and subtract 3x. So it's going to need 2 x's minus 10 equals then 9, right? So the overall goal is to get all my x's on one side by themselves. So I got all my x's on one side now, but they're not by themselves yet. So how do I get this minus 10 to go away? Add 10 here, and then you need to add 10 over here. So 2x equals 19. So we've separated variables and constants, and now once that happens, the next step is always division or multiplication. So what do you want to do here? Divide by 2. So divide by 2, what do you mean 19 over 2? Now I'm just going to leave my answer that way, because is it easier, think about this, is it easier to just leave that as 19 over 2 instead of getting my calculator out and changing it to 9.5? 19 over 2 is, you're done there. You don't have to do anything else. Huh?
I had 9.5.
That's 19 over 2. How'd you get 9.5?
I had negative and
Yeah. So you took 19 over 2. Did you put it in your calculator and you get that 9.5 back?
yeah.
And here's my argument to that. To get that 9.5, I've got to do either extra mental math here, or I've got to grab my calculator and do more work. If I leave it as 19 over 2, we're done.
Well, I was confused because I had negative 19 and negative listed, and I thought that I had.
Okay, so if you got negative 19 over negative 2, I don't know what math Excel is going to do, to be honest with you. I don't know if they'll say that's simplified or not simplified. But a negative divided by a negative is always a positive. Now, here's what I would do. Let's get Desmos open here. I would just type in the left-hand side of my original proportion, x minus 2 over 3. And we'll type in the right-hand side as a new line, x plus 3 over 5. Now, it puts these errors or caution signs here because it doesn't know what we want x to be. Well, don't we want x to be 19 over 2? And if we see this, okay, that number there and that number there, so it's the left-hand side, that's this side here, this is the right-hand side right there, are they actually indeed equal to each other? Any other number other than 19 over 2 will produce something or a set of values that are unequal. Okay, so that's what the process of this equation was, to find the one value that equates those things. Okay, so something we can do? Let's do another one. Give me a number. 2. Give me.
9.
I'm
9.
just trying to keep it so that things aren't like real crazy here. Let's go 3. All right, so let's just solve for x here. I'm going to take that and multiply by that, right? Okay, so I'm going to rewrite that as 3 times 2x minus 7. Then we'll multiply these. Okay, so we get 200. Well, I'll just write it 10. 10 times 20 plus x, right? Okay. When we cross multiply here, those are the things that show up. So now what do I have to do here in the orange? Okay, so it gives me 6x minus 21 equals 200 plus 10x. Good. Okay. Now what do you want to do? Add 21? No, you said add 21. Good. So I get 6x equals 221 plus 10x, right? Okay. So now what would be the best thing to do? Subtract 10x. Yep. So now, what am I going to do now? Well, let's think about this. If I take 4 and start multiplying it by 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, can I multiply 4 by anything and get a 1 in the units place of that product? No, you can't. Okay. Because 4, so what's going to happen, think about this. If I start multiplying things by 4, I'm going to get, so 4 times 1 gives me 4, right? 4 times 2 gives me 8. 4 times 3 gives me 12. 16. 20. 24. 28 first, right? 32 next, right? Okay, so here's the deal. 4, 8, 2, 6, 0. 4, 8, 2. What do you think the next one's going to be? 6 and then 0, right? So that's cyclical. That's going to keep happening. So what I'm trying to say is that you're never going to get to 221, are you?
I never realized that.
Okay. So you're never going to get to 221. So 221 and 4 are not divisible by one another. For the same reason, I could do 2's, divide by 2, because 2 is a factor of 4, but 221 is not going to divide by 2, right? So here's my philosophy. What's going to be easier, to leave it that way, or to get my calculator out and type it in my calculator and hit enter? Which one is more time saving? This one, right? Just leave it that way. 22 over negative 4, that's one. Okay. Now, as we're, because I asked you guys to kind of arbitrarily give me some values here to create the proportion, we're probably going to get ugly numbers back, right? But that's fine. Okay. Let's do one more.
12, 4, 8, 2, 1, 7.
All right, let's take a minute, see what you come up with. Why don't you do that one on your own?
Wait, come on.
Excuse me? Was what good? My water? Delicious.
The water is no good. What does? It's nasty. It's like
You know they're all the same one?
no. Your face.
Okay, so when we cross multiply, we get 2 times the quantity 9 plus 12x equals 4 times 20 plus 8x. We get what's in purple there, right? If we write that down, guys, I have confidence in us that we're going to be able to go through the rest of this. Okay? I distribute the 2. It gives me 18 plus 24x. I distribute the 4. It gives me 80 plus 32x, right? At that stage, and this is what, and we've talked about this several times, at this stage, you've got options. There's 4 different things you can do there. Okay, I decided to subtract the 18s from both sides. If you want to subtract the 80s from both sides, you can do that. If you want to subtract 24x from both sides, or 32x from both sides, you could do it. Okay? So it doesn't matter. I subtracted 18. Eventually got 24x equals 62 plus 32x. And I need, now at that stage, I need to realize I need to get all my x's on one side. So subtract 32x from both sides. So negative 8x equals 62. Now, does that reduce at all? What number will divide 62 and 8? 2. 62 cut in half is 31. Negative 8 cut in half is negative 4. Now, can I put that negative up with the 31? Yes, so these are all equivalent formats. Negative 31 over 4 or negative 31 fourths, like that. Okay? Stop it. I'm kidding.
Mr. Moore does the thing where if you sneeze 3 times, you have to get out of the room.
Why?
Because he says, like, it's bad. It's like, it's
Bad
bad
luck?
luck.
Bad luck?
Yeah. I said Moore. Mr. Moore is cool.
All right. Let's come down here and do some of these story poems.
Here, ooh.
All right, it says, so this first one says a portable hard drive has 2 gigabytes of storage, holds 500 songs. Okay? I think a question like this makes sense to maybe even go back to section 2.6 where we dealt with ratios and rates and those types of things. Basically, we're going to rewrite this as 2 gigabytes for every 500 songs. Does that make sense? Or if you want to, 500 songs for every 2 gigabytes. But there's information there that is linked, information there that's linked that we need to understand. So a similar but larger hard drive has 80 gigabytes of storage. It wants to know how many songs will 80 gigabytes store. Okay? So my hopes are that you see that 80 gigabytes and how many songs are linked together. So the question that they're asking us should be linked to the 80 gigabytes. Does that make sense? Now the reason I'm talking about these links is because we want to create a proportion to solve this. Would you say that for every 2 gigabytes, this is why I think it's important to maybe talk about the ratios we talked about in the last section, for every 2 gigabytes, you get 500 songs? Does that make sense, everybody? So now, I can break that down. I can divide that out, and it gives me a unit rate. And that unit rate would be, you don't need to write this down, but if I were to divide that, it would give me 0.004 gigabytes for every 1 song. Does that make sense? So this here has built into it, if I were to reduce it, it has built into it a conversion factor that allows me to take gigabytes per 1 song. Okay? Or, and this might make more sense, I can go 500 songs divided by 2 gigabytes, and that means then for every 250 songs, it's 1 gigabyte, right? Okay? So now, if I use that, but I got 1 gigabyte gives me 250 songs, so now I got 80 gigabytes, right? Well, what do I do with that 80 gigabytes then? What can I multiply it by? 250.
You multiply by 500 too.
Okay.
Or no?
Not if I'm going to multiply it by 250 over 1. Okay.
Yeah.
So here's the idea, guys. I don't want to and everybody's I don't want to have to think about how can I convert this down to a unit rate or something like that. So you're probably not going to do what we just did there or what you're going to do right here. You're going to start and say, okay, in that green, I have a relationship between gigabytes and how many songs that will hold. I want then in my next ratio to kind of abide by the same structure. I want gigabytes over songs because that's what I had in my first ratio, right? Okay, so in that second ratio, what do I know? Do I know gigabytes or do I know songs? I know 80 gigabytes. Songs is how many, right? It says how many songs. That's the question. Let that be X. Okay. So now when I cross multiply, you get 2X equals, now what's 5 times 8? 40. And then you have 100 times 10, right? So I get 40, and then I'll have 3 more zeros on it. So now if I divide by 2, what do I get? 20,000. So it tells me 20,000 songs. Well, does that make sense? Go back to what we said earlier. It said for every 250 songs, it consumes 1 gigabyte. If I take 250 and multiply it by 8, what do I get? Think about this. If I have 25 cents and you multiply it by 8, how many dollars you have?
25 times 8, you have $2.
You got $2, right? So if I take 250 times 80, okay, I add 4 zeros to that $2 essentially. Does that make sense? Okay. But I think it makes sense to kind of recognize how many gigabytes for every song or how many songs for every gigabyte, and then write the same structure for the second ratio. Okay, you'll see a lot of questions like that. Ultimately, guys, so is that any different than these questions up here? I guess it would be these here. It's the same as these, right? Okay, so here's the thing, though. The end of course exam wants to judge whether you are going to be confident enough in algebra to use this stuff outside of high school. Well, outside of high school, I'm not going to see 4/3 equals x over 8 anywhere in front of me. But I might be a consumer and I have to figure out, okay, do I want to buy the new iPhone that has this many gigabytes and can hold this many songs, or do I want to buy this many gigabytes so it holds this many songs? Does that make sense? Okay, so that is maybe something that's more applicable outside of the school setting. So that's the type of question the end of course exam would kind of target. Okay. This next scenario is common as well, but I want to save that to the end of class. So let's come down here and do this one. I give a little bit of description here. This is actually, and I hate that they do this, this is something you'll work on a lot in geometry, but for some reason they like to use this process when we talk about proportions in Algebra 1. Thank you. Yeah. They, as you read this description, it says geometric figures, relationship, and similarity sometimes exist between two shapes. When we talk about similarity, all that means is that your two shapes are the same shape, but one is either enlarged or shrunk. Does that make sense? So basically, it's like I cut and paste one of them, and then I zoom in on it, or I stretch. You know, when I do a cut and paste, I grab the bottom right-hand corner of that crop window, and I stretch it, right? And that will enlarge or reduce the image. Those shapes then are said to be similar. One of the physical world applications of similarity is that it allows us to measure things without physically measuring it. Okay? Meaning, let's say that I have a tape measure, but my tape measure is only 15 feet long. That's the max of my tape measure. That building is going to be bigger than 15 feet. So I don't want, or maybe I'm by myself, or maybe I don't have a ladder to the top of this building. But I want to know for some reason how tall that building is. I got to know it. If I don't have the tools, the resources, or the other people that I need help with to actually measure that distance. However, if I understand how physics works, I should be able to do this. Okay? Basically what it's saying is that when the shadow is cast by the sun, so sun's light hits this corner, right? Okay? And light is not able to get to the ground, so that's where we create this shadow. Basically what happens if that's a right angle and that's a right angle. Okay? Would you guys agree that when you stand straight up and down, you are perpendicular to the ground? Yeah. We're going to assume that when this building was built, they made it perpendicular to the ground. Okay? Because of the way that the sun's rays hit these objects, that angle right there and that angle right there are going to be the same as well. And that fact is what you'll investigate in geometry, but that's enough to say that these two triangles are similar to one another. Okay? Yes. Geometry integrates two, but they're the same thing. Okay, so that physics says that when this happens, so you'd have to do this at the same time of the day. You wouldn't want to do the shadow of the building at 3 o'clock and then the shadow of the girl at like 7 o'clock, because the position of the sun has changed, right? So that means those angles down there at the ground would have been different. So the triangles would be non-similar. But we're looking at that triangle right there and that triangle right there now. If we look at those, the argument is the shadow that is cast by the person, the shadow of the girl, compared to her height, should equate. So if I look at that ratio, divide that out, where the shadow of the girl is compared to the height of the girl, that should be the same as the shadow casted by the building divided by the height of, spell building, abbreviate building, right? Building. Okay, BLDG is what I got right there, building. Does that kind of make sense? Shadow divided by height is equal to shadow divided by height. That is of anything. Okay, so if I were to go out and measure the height of those statues out there in the courtyard, we could measure their shadows on the ground right now. We could stand out there and measure our own shadow. Okay, know how tall we are, because that's something we maybe already know or can measure quickly, and we can instantly find the height of those statues. Okay, or those, whatever those are, monuments, whatever. So shadow of the girl, using this information, is 3 feet, right? Height of the girl is 5 feet. Okay. Over here, okay, what was the shadow of the building? 15 feet, right? What's the height of the building? We don't know that. That's X. Is that a proportion? Okay. So we set this proportion up. We're going to cross multiply, right? Do we end up with 3X equals 75? Divide both sides by 3. What's X going to be? X is 25. X is 25 feet. Which now, and that's going to be, as long as my 15 feet, my 3 feet, and my 5 feet, as long as I took those measurements and they are accurate, that 25 is going to be accurate. Okay? That's called indirect measurement. Okay? If we do something directly, if I directly measure something, that means, you know, in this case, we probably took a tape measure and measured this girl's shadow, right? Put tape measure end right there, right, put the other end right there, and I directly measured her shadow. Does that make sense? I used the device and lined it right up next to her shadow and measured it. I did the same thing with her height. I lined her up with a ruler or a tape measure, and I measured her height directly. The same thing with the shadow of the building. Did I do that with the height of the building, though? We never put a tape measure next to the height of the building, right? But we went through the use of a formula, a proportion, an equation, that gave me the height of the building without me having to physically touch the building. And that's called indirect measurement. Find the measurement of something without physically measuring it. Okay? And we use that, and you think about our sciences, we use that all the time. Okay? We've never been outside our solar system. Or not, I want to say that. We haven't been outside our galaxy. Okay? I don't even know if we've created things to go outside our solar system. I have to look at that. But we know the distances between things outside of our galaxy. We know how far galaxies are away from us. We know a lot of information like that, and it's because, not because we've been there and we've been able to hold a tape measure next to things, but we know how fast the light is, how fast light travels. Okay, and because of that value, we can measure distances between things by observing light and intensity of light to measure distances between two things very accurately. Does that make sense? Okay. Indirect measurement is a tool that we use a lot. Okay. Now this one's more kind of applicable to us because it's easier. Okay. We don't need all those instruments and telescopes and that kind of stuff. But proportions, these equations are useful. Okay. This one you've seen before. Basically what it's doing says you've got a map here of Florida. So there's not Florida. And so Jacksonville is right there. Orlando is right there. Down at the bottom, doesn't every map that we come across have a key down there? Yeah. What this is saying is if that is 1 inch in real life on my map, it's 110 miles. Okay? So I have to read this on a particular map of Florida. A scale of 1 inch is the same as 110 miles. Okay? So when laying a ruler on the map, so you lay your ruler right next to Jacksonville and Orlando, and you measure the distance between those two things, you find out that that distance is 1.25 inches. to determine the actual distance between the two cities. So, if I want to do this, I have 1 inch providing 110 miles in real life, right? So in my ratio on the right, what should be my units of my numerator? Should be inches on top, right? We talked about how numerators need to kind of have the same thing, okay? Wherever these units were in this order, I'm going to try to keep them over here. And I put miles there. Okay, so if that's the case, what number should go with inches over there on top? 1.25. And then miles should be what we're looking for, right? Now, if I cross multiply, x times 1 gives me x. And I get 110 times 1.25. I'm going to do it this way. Is this still, if I say 100 times 1.25 plus 10 times 1.25, does that still say 110 times 1.25? That's the distributed property kind of backwards, right? What's 100 times 1.25? If I multiply by 100, how many decimal places do I need to move? I just need to move 2 to the left, or 2 to the right, correct? So that's going to give me 125. If I multiply something by 10, how far do I need to move the decimal place? Just once, right? So it gives me 12.5. Can I add those together and get 137.5? Now, I would argue that most of us right now maybe are going to grab calculator, type 110 times 1.25. My hope is that down the road eventually that you do this enough that you say, it makes more sense for me just to logically use the distributed property, get 125 and 12.5, add them together, and get 137.5. Okay. All right, so the next question is where I copy this explanation. I'm not going to read that explanation to you. They call it the mark and recapture technique. Sometimes they call this the capture-recapture technique. But if you're interested in like biology, okay, I think the paragraph up there talks about marine animals, so marine biology. But it doesn't really matter. Just biology and maybe conservation. Something that those people are interested in is how large a certain population of animals is. Okay. Anybody in here hunt deer or anything like that? Okay. Okay. So every year the ODNR comes out, Ohio Department of Natural Resources comes out and tells us what the population of deer in Ohio is, right? Well, how did they call a meeting and had all the deer show up and say, hey, we need to count you guys because we're about to slaughter you here pretty soon? No. Okay. They're using math to get an idea. And it's a very good idea of how many animals are actually in Ohio that are deer, okay? And this is the process they go through to figure that out, okay? So what they do is they go out, okay? So in Ohio, maybe across Ohio, well, there's 88 counties. Maybe each county has a group that does this, okay? Or maybe each region, maybe a 2 or 3 county region has a group that does this in their area. And then they report all this stuff to the ODNR. ODNR adds it all up. Does that make sense? So, like, doing this across the entire state would be very difficult, okay? But inside maybe a county or a 2 or 3 county area would be a little bit easier. But what they do is the researchers go out and they tag deer or whatever animal they're looking at, okay? So they go tag it. So they just go out and they say, okay, today we saw 50 deer, and we put tags on 50 of them. Does that make sense? Okay. And then they let them go. Then a week later or they put a duration of time in between, and they go back out a second time in the same area, and they collect another amount of deer or see another amount of deer. Of those that they see, some of them are going to have tags on them. Does that make sense? Some of them aren't. But the ratio of the ones that have tags to the ones that they found in that second capture is proportional to how many they found initially, the 50 initially, out of the entire population. So I gave an example down here. talking about rats. So let's say maybe we're in maybe a city block here or something like that, but it says a pest control technician captures and applies ear tags to 23 brown rats. Okay? Now, that 23 brown rats, that is out of how many rats exist in this environment, right? We don't know the population of rats in the environment. We have no idea what it is. Okay? But he tags the ones that he catches, and he releases them. Okay? Time goes by, he comes back a week later, and he traps 29 rats. Okay? Of those 29 that he caught the second time, 11 of them had tags on. So 11 of them were the ones he caught the first time, right? So right now, we have 11 tagged rats out of 29 rats that I collected that second time. Does that make sense? So that 11 out of 29, whatever that is as a ratio, is equivalent to the 23 brown rats out of the entire population that I got to choose the 23 brown rats out of. Does that make sense? So right now, what I'm going to do, I'm going to write another ratio. And if you don't fully understand that concept, you should hopefully understand the mathematics that says, if I had tagged rats up here, I better have tagged rats down over here. And if I had rats down here, then I just have rats there. And I need to fill in some numbers, okay? 23 brown rats were the ones that I collected the first time and tagged, right? And remember, we said out of the population, which we don't know, that's where we got those 23. And that's what I'm trying to ask. How many are actually in the population? So that's going to be X. If I cross multiply, I get 11X. 29 times 23, that's 667. And I'll divide by 11. Does this give me 60.63? Okay. So I'm going to just round up. And usually, guys, when you have this situation occurring, these are estimations. Okay. What I would do as a biologist is that I would do this one time, get my 61 rats. Then I would do it a second time, maybe I get 63 rats. I would do it a second time or a third time, maybe I get 64 rats. Does that make sense? And I would do this as many times as feasible as possible, and then I would take the average. Okay, and that would tell me maybe the best size of the population. Does that make sense, everybody? But this is saying then we can be pretty confident that there's around 60 rats in this population, 61 rats. Okay, now it fluctuates a little bit. Okay, but when you see, at the end of the deer season or whatever, they'll come out and say, this is how many deers were tagged or how many hunters brought tags back or whatever, and this was the amount of deer that we started with, and they'll give that data. How do they know what that deer population was? This is how they know. Okay, if we go to, anybody fish? Go to Lake Erie. Okay, they said Lake Erie had this year one of the best years for walleye fishing they've ever had. Okay, and they were giving numbers about the fish population. Well, I can't see through the water and see how many fish are there, right? It's this capture, recapture thing. Okay, so that's, I think, more applicable to us, and it gives us a little bit of context for these types of problems instead of just giving you guys this type of stuff and say, solve that proportion. I want you to see where that proportion is used. I've seen in previous end-of-course exam questions kind of this capture, recapture technique being asked. Okay, so I want to make sure that we do see it a little bit. No new homework tonight. Okay, the 2.7 assignment that I opened yesterday is currently still open and is not due tonight. It's due tomorrow night. Okay, so yesterday's homework that you started working on is not due until tomorrow evening. Tomorrow the goal is to start percents. Okay, and all this stuff is that it's all intertwined. Okay, portions relate to percents, relate to change in percent and stuff like that we'll talk about towards the end of the week. Okay. Yes. Yes. Make sure you sign up.